this episode, we're going to talk about something that sounds almost too simple to be a security topic until you see what breaks when it is wrong: time. In a payment environment, reliable time is not about being punctual or having clocks match a wall calendar. It is about being able to trust your own records. When something suspicious happens, you need to know what happened first, what happened next, and what happened at the same time. And that requires systems to agree on the time. If your firewall thinks an event happened at 2:03, your server thinks it happened at 1:57, and your application thinks it happened at 2:11, you do not have a story you can follow. You have a puzzle with pieces from different boxes. For a PCI QSA assessment, time synchronization is one of those controls that supports everything else, because logs, alerts, investigations, and even basic accountability depend on it. A beginner-friendly way to see it is to treat time as the glue that holds evidence together. Without reliable time, the environment can still function, but the organization loses the ability to prove what happened. And that is exactly the moment when both attackers and operational mistakes become harder to detect and contain. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. To understand why time synchronization matters, it helps to focus on what a log entry really is. A log entry is not only a message about an event, it is a message tied to a moment. The moment is how you correlate events across different systems, and correlation is how you discover patterns. If an attacker signs in remotely, escalates privileges, modifies a configuration, and then exfiltrates data, those steps will appear as separate events in separate places. The only way to confidently connect them is to align time. Even in non-attack situations, time alignment matters because teams troubleshoot incidents by comparing what users experienced to what systems recorded. When time is off, the team can waste hours chasing the wrong root cause because the sequence appears different than it truly was. In payment environments, where outages and suspicious behavior are high impact, those wasted hours matter. A QSA looks at time synchronization not as a technical nicety, but as a foundation for monitoring and response. If an organization cannot trust time across the environment, it is not truly in control of its evidence, and that weakens the credibility of every other control that depends on logs. A common misconception is that time synchronization is only for servers or only for systems that generate security logs. In reality, any system that participates in authentication, authorization, payment processing, or security monitoring benefits from synchronized time. Network devices, operating systems, applications, databases, security agents, and centralized logging platforms all contribute pieces of the overall picture. If one layer is out of sync, the picture gets distorted. Beginners sometimes think a few minutes of difference is harmless, but minutes are enough to confuse investigations, especially when automated systems respond in seconds. Time drift can also create false positives, such as a monitoring system interpreting normal behavior as suspicious because events appear to happen out of order. In a PCI setting, another subtle risk is that time drift can affect how long sessions appear to last, when access appears to occur, and when changes appear to be made. That can lead to incorrect conclusions during an assessment, and it can also create gaps in operational controls like account lockouts or certificate validation events that rely on accurate time. So the goal is not just to make clocks match. It is to make time reliable enough that security and operations can trust it. Reliability in time synchronization comes from a simple principle. Systems should not each decide time on their own, and they should not depend on an uncontrolled source. Instead, time should flow from a trusted reference into the environment in a consistent, managed way. You can think of it like a choir needing a conductor. Without a conductor, everyone sings at their own pace, and the song falls apart. With a conductor, even if individuals are slightly off, they quickly correct back to the shared rhythm. In a payment environment, the trusted reference is whatever the organization uses as its authoritative time source. The environment should have a defined hierarchy, where key systems obtain time from trusted sources and other systems obtain time from those key systems. This reduces confusion and makes the environment easier to validate. As a QSA, You are trying to confirm that this hierarchy exists, that it is documented, and that it is used consistently across in-scope systems. Consistency is the signal of control, while inconsistency is the signal of drift. Drift in time synchronization is particularly sneaky because it can happen gradually and remain invisible until you need logs during an incident. Systems can drift because their internal clocks are not perfectly stable, because they are misconfigured, because they are isolated by network changes, or because they were built from images with incorrect settings. Drift can also happen when devices are replaced, virtual machines are moved, or networks are segmented in ways that block time synchronization traffic. The organization may not notice because daily operations still appear normal. The problem appears when investigators try to build a timeline and discover that different systems tell different stories. This is why time synchronization should be treated as an operational control, not a one-time setup task. A mature environment monitors for drift, verifies synchronization status, and responds when systems fall out of alignment. For a beginner, it helps to think of time as an ongoing service the environment provides to itself. Like power or network connectivity, it is something you maintain, not something you configure once and forget. Time synchronization also ties directly into the quality of evidence during a PCI assessment. A QSA often requests log samples to demonstrate that logging is occurring and that events are traceable. If those logs show inconsistent timestamps, it raises questions about whether the organization can truly monitor and investigate. Even if the organization has strong access controls, strong segmentation, and strong file integrity monitoring, weak time synchronization undermines the ability to prove those controls are working in practice. It is like having security cameras with incorrect timestamps. The footage exists, but it is harder to use. A QSA will look for evidence that time is synchronized across relevant systems and that the organization has a policy and process that describes how it is achieved. Importantly, the validation is not about forcing a single implementation detail. It is about verifying that time synchronization is deliberate, reliable, and broad enough to support the environment's logging and monitoring needs. Another misconception is that time synchronization is mostly a technical concern and does not involve people and process. In reality, process is what keeps time reliable when things change. When a new server is deployed, the build process should ensure it joins the time hierarchy automatically. When network segmentation rules are updated, the team should confirm that time synchronization paths are still permitted for the systems that need them. When third-party services are integrated, the organization should consider how timestamps from those services align with internal timestamps. When incident response occurs, investigators should know where to look to confirm time alignment before they interpret logs. These are process behaviors, not technical settings. For beginners, this is a good example of how PCI controls are often as much about operational discipline as about technology. A QSA will pay attention to whether the organization treats time synchronization as part of the change and release culture or whether it is left to chance. System time also affects more than log correlation because many security mechanisms rely on time to function correctly. Authentication can involve time-based elements, and session lifetimes and token expirations are time-related concepts. Certificates have validity periods, and systems need accurate time to validate them properly. If time is wrong, a certificate may appear expired or not yet valid, which can cause secure connections to fail in unpredictable ways. That can lead teams to make risky workarounds, like disabling validation checks, which creates a bigger security problem than the original time drift. Even without getting into implementation details, the beginner lesson is that time influences trust decisions. Systems constantly make decisions based on whether something is current, whether something is timed out, and whether something is within an acceptable window. When time is unreliable, those decisions become unreliable, and reliability is the foundation of security. In a PCI environment, you want security decisions to be stable and auditable, not erratic. When thinking about validation, it helps to picture what good evidence looks like. Good evidence tends to show that the organization has an identified authoritative time source, that systems are configured to use it, and that the organization periodically verifies synchronization status. It may also show that exceptions are handled thoughtfully, such as isolated segments that use internal time distribution while still remaining aligned. The evidence is not only technical screens or reports, it can also be procedures and records that demonstrate the control is maintained over time. A QSA is looking for proof that time synchronization is not accidental. If the organization can show a consistent pattern across different types of systems, it suggests a coherent approach. If the organization can show that they detect and correct drift, it suggests operational maturity. Beginners should notice how this mirrors the validation mindset for other controls. It is not enough that the control exists. It needs to be maintained, monitored, and evidenced. As we bring it together, remember that reliable time is one of those foundational controls that becomes visible only when it fails. When it fails, logs lose value, investigations slow down, and teams can misinterpret events, which can lead to wrong decisions at the worst possible moments. In a payment environment, you do not want to discover time drift during a breach investigation or during a critical outage. Synchronizing time across the environment is a way of protecting the integrity of your evidence and the speed of your response. From a QSA perspective, validating time synchronization is about ensuring the environment has a trusted reference, a consistent distribution model, and an operational process that keeps systems aligned as the environment changes. If you keep the glue metaphor in mind, it becomes clear why this control is so important. Time holds together the story of what happened, and in PCI, being able to tell that story with confidence is a core part of demonstrating security.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.